Welcome to today's lesson, everyone. And it's not really a lesson. We are going to start our study guide for the test. It's actually going to be kind of a 2-day study guide. So we'll do it on Friday or today of this week, and then we'll do Monday of next week, and then our test will be on Tuesday of next week as well. One thing I did notice is that in the past, a lot of people would confuse if something was a function or not with if something was linear or not. So I wanted to kind of go through a few examples just to clear up any confusion that there might be with those two. Okay, so let's start with if something was a function or not. If you remember, this is when we looked at our domains or the x's and we saw if any of them repeated or went on a date with two different people. So if we look at the ordered pairs, and this is the 4 different ways we could see it. So we could see as a graph, a table, ordered pairs, or mapping diagram. Okay, so let's look at the ordered pairs first. So if you look at the domains, again, we're looking to see if any of the domains go on a date with 2 different people or are paired with 2 different ranges if we're talking mathematically. In this case, -2 was paired with 1, and then over here, -2 was paired with -1. Okay, so that's why that would be not a function. In the mapping diagram, here we have 3. 3 was paired with both 9 and -1, again, making it not a function. In this table, we had -2 paired with 1 and -2 paired with -1. Again, not a function because of that reason. And then in a graph, we kind of had a shortcut. We had the vertical line test. So what we did is we drew a vertical line, and we saw how many times the graph hit that vertical line. And remember, each time it hit, it was a date. So this person had 2 different dates, making that one not a function. Okay, so these are 4 examples of non-functions. Now, if something was a function, then we went even a step further. We decided, is that function linear or nonlinear? So does the function form a line or not? Okay, so just a quick refresher of what that meant. For linear, the graph was a straight line. For a table, we had to have a constant rate of change on both sides. For ordered pairs, again, we had to have a constant rate of change in our x's and a constant rate of change in our y's. And you could have made a table to help determine that. And then if I'm given an equation, the exponent had to have, the x had to have an exponent of 1, or that ninja 1. A lot of times it's the unwritten 1. So those were all examples of functions that were, sorry, those were examples of functions that were linear. Here are some examples of functions that are nonlinear. So it does pass the vertical line test, but it doesn't form a straight line. That's what the graph looks like. Okay, again, functions, none of the domains repeat, so it's a function, but it's not a constant rate of change, meaning it's not linear. Okay, ordered pairs, again, none of the domains repeat, so it's making it a function, but in terms of if it's a constant rate of change, our y's or our ranges were not a constant rate of change, making, again, not linear. And in the equation, anytime the exponent wasn't 1, it was nonlinear. Okay, so let's just do a few quick examples, and then you guys can work on the stations. And again, this is kind of Friday's lesson and next week's Monday's lesson. Okay, so first off, let's determine if it's a function. So that's when you look at your domains. Do any of them repeat? Well, yeah, our 3. So 3 is paired with 10 up here. 3 is paired with -10. Is this a function? No, it's not. Okay. If it's not a function, there is no need to decide if it's linear or not, because it's not even a function, so we don't even go to that question. Okay, so let's do another one. All right, is this a function or not? Well, I'm going to turn this into a t-table because it's easier for me, well, to kind of look at. So -4, 10, -2, 15, and 0, 20. So is it a function? Do any of the domains or the x's repeat? No, they don't. So I know it's a function. Now I have to decide what kind of function. Is it a linear function or is it a nonlinear function? And that depends on the rate of change. So let's see if it's a constant rate of change. So our x's are going up by 2. That one was constant. So let's look at our y's. Our y's were also going up, but this time they're both going up by 5. Again, constant rate of change. So this is a linear function. Okay, let's try one last one. I'm going to look at my domains. None of them repeated, so I know it's a function. And to see what kind of function, I'm going to put it into a table. Again, I see that a little bit better. So, oops, I would have to do 8, 5, 7, 3, 6, 2, and 5, 3. All right, so I can already tell it went 8, 7, 6, 5, so it was going down by 1. That's good. But if you look at your y's, it went 5, 3, 2, 3. That was definitely not a constant rate of change because it went down 2 here, down 1, and then it went up 1. So not constant rate of change. So this is a non-linear function. All right, so again, hopefully that cleared up the difference between if it's a function or not and if it's linear or not. There is also a tree diagram that looks like what I went over in the first few slides. I've included that if you want to look at that for a little bit more help. Again, if you have any questions, please let me know because we're going to have our test on Tuesday of next week. All right, hope to see everyone soon. Bye.